Okay, today we're going to look at drawing quadratic graphs using a different form of the equation. Up till now we've looked at the standard form, which our equation looks like this. We have an example 2x squared minus 12x plus 13. So if we graph that on our calculator, we get a quadratic that looks something like that. Okay, and now let's analyze what each of these numbers actually mean, and maybe that'll help us understand what's going on. So remember the A number, that number in front, the 2, means that it's going to be twice as tall, so it's going to look a little skinnier than normal. And because it's positive, we know it's going to be upright. We know it's going to open up, and we know it's going to be skinny or narrow. That's all that 2 tells us. Okay, the negative 12, we get nothing from it. That doesn't tell us anything. We have no idea what the 12 is actually doing in terms of the graph. But the last number, the 13, is actually gives us our y-intercept. We know that our y-intercept is going to be at 0 and 13. And the reason for that is if we plug a 0 in for x, right, 2 times 0 squared minus 12 times 0 plus 13, if we actually solve that, put a 0 in for x, we would get 0 minus 0 plus 13, which is just going to give us 13. So that last number of our equation gives us the y-intercept. That's the only thing that we know for sure in this equation. So there's other forms of writing the equation that sometimes are more useful. The one we're going to look at today is the vertex form. So on your calculator, graph y equals 2x minus 3 squared minus 5. So it looks like a totally different equation, but when you graph it, what happens is we get the exact same graph. So if you do it on Desmos, you'll see a different color. If you do it on your graphing calculator, it just looks exactly the same. But in actually what's happening is it's graphing the new one right over top of the old one. So we get equal graphs. So that means these two equations are equal. And in Math 20-1, you have to convert back and forth. Math 20-2, we don't. So we just basically have to know that if we have an equal equation, it just means that it's going to give us the same graph. So you can graph them and see if they match or not. So in this case, they do match. So now let's go through each of the numbers again to kind of see what's going on. The 2, still exactly the same as the 2 in the first one. That's still going to tell us it opens up. And it's going to be a little bit narrower. Okay, but other than that, it doesn't do anything else. We don't have the 12 or 13 anymore, but what we do have is a negative 3 inside the brackets, and then we have a negative 5 outside the brackets. So those two numbers there are actually fairly important, and they clue in. The reason we know why they're important is, and that's why we call it the vertex form. So on your calculator, if we go second calc max, or min, in this case minimum, because it's a bottom part, and we actually find that vertex, so hit enter on the left side, hit enter on the right side, hit enter again. It gives us, on that graph, the exact same graph, it's going to give us the location of the vertex, which is at 3, negative 5. So if we look at our original equation, kind of compare that to the vertex form of the equation, you can see that the negative 3 and negative 5, the way it's written like that, is pretty close to our location of the vertex. The thing we have to remember is, in the first part, the negative 3, we have to do the opposite. If it's negative 3 in the brackets, our vertex coordinate for the x is going to be positive 3. And then the negative 5 that's outside the brackets stays the same. And that's it. So the vertex form will give us the vertex. It doesn't give us the y-intercept, right? We didn't know that the y-intercept was 13. We did in the standard form. In this new form, we don't. So standard form is good for y-intercept. Vertex form is good to give you the vertex. So let's do one or two more quick examples. So if I gave you an equation of negative 5x plus 2 squared and plus 4. We draw that graph on our calculator. I'll just type it in quick. It's going to be a quadratic, and it's going to look upside down, kind of skinny, It's going to do something sort of like that. Okay, so once again, we know the -5 means it's going to be upside down and pretty skinny, which it is. But now, more importantly, we want to figure out what that vertex is. So looking at the equation, we have +2 and +4. But remember the +2, because it's inside the brackets, we have to do the opposite. So it'll be -2, and then the +4 stays the same. So that's our location of the vertex. It's going to be at -2 and +4. And you could use your calculator, or you could use Desmos to see that that's true. Okay, let's do one more. So let's suppose I give you nothing out front, so we just have a 1. Let's do x minus 1 squared and plus 6. So if we graph that one, in this case our graph is somewhere up here. It looks kind of like that. And once again, if we calculate the vertex on your calculator, find that location, you can do that just like we normally would, second calc minimum. But in this case, we don't need to because we have the equation. So we'd have the vertex is going to be at +1 and +6. So remember, it's always the opposite of the brackets. If it's inside the brackets, you got to do the opposite. And the y coordinate is going to be just whatever's outside the brackets. And that's all.